Hi students, now in this part I'll be telling you something about noble gas, that is your 18th group, okay, and that noble gas group is also included in your P block only, inert gases, all the inert gases. Now, do you think that they do not form any compound? Really? But you will see that they will. And what is the condition, that also I will tell you in this part. So be ready for that. Hi students, now in this part we have to learn about noble gases family. This is the 18th group, guys. This is the last group of P block element. So it consists of helium, neon, argon, krypton and xenon. These all are what? Inert gas. They do not react as much. And all are present in gaseous form. Okay, and exist in atomic form. What are the chemical properties? That they are inert in nature. Okay, they do not participate in chemical reaction very easily. Then why this inertness is there? The reason is that it has stable configuration. Octet complete. So, and also having high ionization energy. Okay, they have high ionization energy, guys. And very low electron affinity means it cannot add also electron, it cannot remove also electron. Octet is complete and that is very, very stable. But Bartlett observed that O2 when reacts with PTF6, it forms that compound. So this compound O2 get oxidized by the PTF6, then he tried xenon, okay, rather than your O2 by direct interaction, and the first compound which was obtained of noble gas was XCPTF6 in the form of red crystalline solid. So Bartlett proved that it's not the case that they cannot react, okay, they react in some situations. So compounds of xenon are, they may be in fluorides, oxides and auxiliary fluorides. Three basic fluorides for xenon are XeF2, XeF4 and XeF6. When your xenon it's heated with nickel tube, okay, directly with fluorine, it gives you fumes. Like this way. Xe plus F2 1:2 in a nickel tube, it will give you XeF2 fumes. Then Xe plus 2F2 1:5, this will give you XeF4. Xe plus 3F2 in nickel tube, again XeF6. Now we'll deal about the structure, that how your xenon compound structure look like. These XeF2, XeF4, XeF6. So these all are told about on the basis of VSEPR theory and as well as your hybridization theory. Let's have a look. So if I have XeF2, how many electron pairs I will be having? I'll be having 5. If XeF4, then 6. XeF6, then 7. So if I can calculate the hybridization, it would be sp3d, okay, because it's 5. For 6 it will be sp3d2. For 7 it will be sp3d3. So my sp3d is your linear in shape. Okay, sp3d2 is square plane in shape and sp3d3 is distorted octahedral. And the structures of these oxyfluorides and oxides of xenon can be best explained by the concept of hybridization. By the hybridization concept means, like in chemical bonding, what you used to do? You just used to calculate the number of electrons, okay? The total number of electrons, like that way. If it is a cation, you will subtract. If it is an anion, you will add, right? And then by that general formula, you used to calculate what is the hybridization, and then according to that you can tell me the shape or geometry of that molecule. So you can see XeF4 is square pyramidal. XeF4 is square pyramidal with lone pairs also there. XeOF2 is T-shaped. XeOF2 is T-shaped. XeO2F2 is distorted trigonal bipyramidal. XeF2 is your linear. XeF2 is your linear. Because of these all lone pairs, they will occupy what? The equatorial position. So it is a linear. XeF4 is square planar and XeF6 was your distorted octahedral. Now the use of noble gas. So first is helium. Helium is used to fill the airships and observation balloons. Okay, helium balloons you must have seen. Then in the oxygen mixture of deep sea divers, there also my helium is used. Then in the treatment of asthma, for the asthmatic patients, they are provided with the helium cylinders also. Then it is used in inflating aeroplane tires. It is used to provide inert atmosphere in melting and welding for easily oxidizable metals. So, suppose I have to weld something, then obviously I am passing what? Oxyacetylene gas, right? Oxyacetylene gas. With that gas, it may happen that the substance will get oxidized. So, not to happen that, we provide an inert environment, and that is provided by helium. That is provided by helium. Next application of neon. Now this is used for filling the discharge tubes, which have different characteristic colors and are used in advertising purpose. Also it is used in beacon lights for safety navigators. So from the far behind you can tell that okay, there is someone, there is some person there. Okay, there is some person there. There is some person there, and then accidental, fault may very less happen. And the last application is of argon. So along with nitrogen, it is also used in gas and filled with electric lamps, because argon is more inert than nitrogen. In lamps, nitrogen is also filled and argon is also filled. Okay. So that's all regarding noble gases family and its application, guys. In the next part, we'll see some of the JEE questions which have already been asked, in competition exams. Stay tuned. So students, in this part we get to know that even inert gases, they form compounds, and what was the condition, that also I told you. Also we saw various application of the noble gases like helium, neon, argon and all. Now in the next part I'll be asking you actually the JEE questions. Okay, so I'll be discussing some of the JEE questions which have already come from the P block chapter. So stay tuned with me for that.